everyone, this is the second part of the two-part step-by-step video tutorial on how to perform heritability analyses in the Voxel-Wise data of the UK BioBank using Solar-Eclipse software. Before we start, you will need to have downloaded the most recent version of Solar-Eclipse software from the NITRIC Solar-Eclipse Imaging Genetics Tools website, as well as the pedigree created in the previous Part 1 video. In addition, it's important to make sure that the data is labeled with the same IDs used in the pedigree or genotype files to avoid confusion. Solar assumes that all subjects have been spatially normalized to a common space, so a Voxel-Wise trait is an estimate of phenotypic variance across all subjects. You'll unpack the UK BioBank bulk data using a command such as this, ukbfetch, where you will be extracting category 5, but you'll need your key provided by the UK BioBank. When you finish unpacking the UK BioBank data, you'll end up with zipped files such as these that contain all of the imaging data. So your first step will be to unzip your files. The easiest way to do that is with a simple script such as unzip.sh, where you can make a directory called unzip, and for every file, zipped file in your current directory, you'll unzip it to base name filef.zip. And then you'll move these into your unzip folder. After you've done that, you'll have all of your imaging data in unzip, which will look something like this. Each participant will have a file that contains all of their data. The data that we're looking for is the skeletalized FA data, which will be in a directory within each of your participant files through DMRI, TBSS, stats, all FA skeletalized data. So once you have all of your data unpacked, it's simple enough to use a script like extract skeletalized fa.sh to extract each FA skeletalized file and add them to your own new file. Once we've run extract FA data .sh, all of our images will be in our skeletalized FA data. So let's take a look at that. Here we have all of our skeletalized FA data for each participant. So the next step is to create a phenotype file that will link the IDs, covariates, and the names of the nifty files containing Voxel-Wise traits. This file can later be used for creating Voxel-Wise phenotype files, so it's important to include all covariates that will be in the analysis. The easiest way to do this is to write a skeletalized FA list in a CSV file using ls, all of your GZ files, into nifty phenfile.csv. Once you have your nifty phenfile.csv, you can open it up in Excel, copy this column into your second column, and then split this one using data, text to column, eliminate with your underscore, finish, and now you have your participant ID, and you can just switch these columns out. And now you have your participant with the correct skeletalized FA data. And while you're doing that, you can go ahead and create a header. So insert a column, have your ID, your FA, which just is labeling your skeletalized FA data. And you can also insert your covariates while you're here, which can just be found using your UK BioBank bulk data, extracting the age and sex. And there you have your nifty phen file separated into your ID, your FA values, and your covariates. So you can save that and put it back in your working directory. We're going to move into our working directory that contains all of our skeletalized FA data. And we're going to go ahead and start our Solar-Eclipse. Most of the time, if you've downloaded Solar-Eclipse correctly, you're only going to need to start it using this last bit, solar. And this is what solar will look like when you first pull it up. So we're going to use the nifty to CSV command, which includes several arguments, including a mask file, so you'll need to have that before you begin this process, and that's basically just a skeletalized example file. Your column name, which if you remember in our example was FA, that's what we labeled those skeletalized files. And the phenotype file that we'll be using, in this case nifty.phen file, what we want our output to be, which is going to be CSV phen file, and the number of traits that we want to include per phen file. In this case, we're going to use 200,000, but this number is variable. So you'll start that, and eventually you'll have your CSV phen file, which also will output your CSV phen file header. If we go into that, this is just a file that contains all your voxels separated by a single space. So if something goes wrong, you can go into your CSV phen file that you just created and ignore ID, age, and sex, because sex and age are going to be your covariates. Copy all of your header and move it into another file and convert all of the commas to spaces, and that'll be your header file. Next step is to regress our covariates using the sporadic normalize command on Solar. And in this case, we're just going to be regressing age and sex from our Voxel-Wise phenotypes. Once we have that, we'll be able to use our normalized output as our new phenotype file. So first, of course, you're going to load your new phenotype. Remember, we just created the CSV phen file. And here it shows all of our header. It doesn't list them all, but it's got the ID, sex, age. So it's always good to double check that you have the correct file when it loads it. Then you'll select our covariates using the covar command. And again, in this case, just age and sex. You can add any covariates that you'd like to your analyses though. And now we can run sporadic normalize. Where we make sure that we include our header that was output when we did the nifty to CSV command. And then we're also going to define what we would like our output file to be. In this case, we're going to call it norm phen file for normalized phenotype file. We'll have an output file called norm phen file.csv. As you can see, it doesn't include our age and sex because that has been normalized out. So now we can actually begin our heritability analyses on our normalized Voxel-Wise phenotypes. We first need to load our pedigree that we created in the previous file with a threshold of 0. This may take a few minutes. We then load our phenotype and then select a single trait. It doesn't really matter which one you use. And create our eigenvalue decomposition values and vectors using the output option UK BioBank EVD. Once the EVD file has been created, we can use GPU FPHI with option list, where we use our CSV theme file header that we created previously, our EVD data that was just output, the out option, which will be the name of the file that is output with our heritability data, and select the number of GPUs. Once GPU FPHI has finished running, we can exit out of Solar and check out our new UK BioBank heritability data, where we'll see our header trait, heritability, standard error, and p-value, output with all of our traits. And if you have any trouble while you're trying to run your heritability analysis on the UK BioBank data, check out our website at solar-eclipsegenetics.org or email one of us at one of these two addresses.